I like this example of the heater install because it shows how easily misunderstood these swimming pool heaters are and how simply making an adjustment that will work actually causes more problems than is it's helping. You can see that draft hood there is 7-inch pipe, and someone has put a piece of metal as a cone to make it go from 7-inch to the 5-inch actually going through the roof for some reason. So they've reduced the size of the pipe, which in turn reduces the gas and airflow out through the top. That reduction causes sooting inside the heater. Now, you also saw there the yellow gas flex pipe inside the heater, which helps contribute to sooting also. And what we're doing now is looking around the room and seeing what the airflow conditions are like inside the room. And from what we see here, there's plenty of airflow inside the room, and that's not contributing to our sooting issues. So we're going to go ahead and fire the heater now and see how it behaves. Turning on the heater, we're looking inside also, and you see the flex pipe going from the main gas line into the gas valve. Definitely another cause for sooting in this heater. It actually disturbs the gas flow enough to cause a sooting condition along with the venting through the top. So now the heater's fired up here. You can see the bright red embers toward the back there, and it shut itself off already. It's going to reattempt ignition. You can see the flame coming down below the burners there, and which is obviously improper. There's something obstructing the gas and flame rise as normal. And we're just getting a better look here at how that flame is behaving throughout the rest of the heater. Again, it's cycling on and off. This heater is sensing improper burn. That flame discombobulation is close enough to the pilot that it's actually disturbing the contact for the flame sensor. So this heater knows there's an issue, but it's not enough of an issue for it to lock itself out and just not run at all. So it cycles. You can see the bright yellow flame. That's due to the flame not rising through the top fast enough and reburning the air around it. We pulled the burner tray out to find out why that flame was coming down around the bottom of the burners instead of rising through the top just in that section, and you'll see it next. With the burner tray out of the cabinet, you can see pieces of fire block have actually fallen down onto the burners themselves. There was a piece close enough to that pilot which was actually causing the flame sensor to recognize a problem and make the heater cycle on and off. So at the moment we're just cleaning it up, and we'll put it back together and fire it up and see how it behaves after we get this taken care of. We also know that the heater sooted up real bad because of the airflow through the top, and we'll check that out here in a second also. After cleaning up and reinstalling the burner tray, we've once again fired up this heater, and we can see the behavior of the flame due to the sooting condition. The flame is not allowed to rise through the top. The soot is significant enough that it's blocking the airflow through the top of the heater and even out the vent that is improper to begin with. So we disabled this heater and are not allowing it to run until that venting is changed and the soot is cleaned up. And once again, we can run it properly. Our still pictures show the pipe measurements top and bottom, which is improper, completely causing the majority of our problem. The flame out sensor and evidence of flame coming out of the front of the cabinet. Looking up through the bottom of the heater, we see the fire block, which has crumbled and fallen apart. We see the black complete blocking of the soot causing us to disable this heater.